Hello, everyone. I thought I'd start this one off by showing off my puppy. Say hi, Dodo. Hi. She's a cute one, I know, but she's very heavy. Okay, so that's one of the ones that always is barking in the videos, and I apologize for that. So today, to do today's activity, you have to have Desmos up. This is going to be a quick video because then you are going to have a actual Desmos activity, but I thought it'd be really good to go over some of the transformations that occur with a quadratics function. So let me go ahead and present, share. So you guys should have this, but if you don't, you can just write this on a piece of paper. That's perfectly fine. And we're going to start with the idea that the parent function, we learned this yesterday, of a quadratic is y equals x squared. So that is the most basic function that you are going to use. Now, the big thing here is that we can make transformations to this graph. And those transformations happen based on an a, and that's the same a from ax squared plus bx plus c, an h, and a k. And this is literally how it's written for almost every function. That's how transformations occur. You're going to see this a lot in the coming years. So that being said, we need to use these letters to determine how to move the graph up, right, left, down, how to widen it, how to narrow it, and how to flip it, which we should already know how to flip it, how to make it a frown. But we're going to go over that again. Now, A is known as the vertical stretch or shrink, and it helps with reflections. The H is for your horizontal piece, going left or right. Think H, horizontal. And then the K, and we'll say horizontal translation, meaning moving up or down. And then, and I know you learned that in 8th grade math, K is your vertical translation. Sorry, this is moving left or right. This is moving up or down. So let's try and change these and see what happens. So first of all, I'm going to go over to Desmos. And we're going to just put in y equals x squared in here. So this is our most basic function. Now, if I want to move this up, remember I'm changing the k, and the k is being added or subtracted. So first of all, I'm going to put in my parentheses, because I will need parentheses eventually, so I'm going to add those in. Now, k is what's being added or subtracted. So if I want to move it up, what do you think I'm going to do? Well, I'm going to add something. So let's say add 4. And as you can see, I'm going to zoom out. If I start, this is my most basic function. Here, we're going to keep the most basic up here. If I have x squared here, that's the red, and I add 4, I get the blue. See how I move up? So that means to move a graph up, oh, Dodo. To move a graph up, we are going to add a positive number to as k, meaning we're adding or subtracting. So I'm going to put a plus 5, not subtracting, sorry, we're adding. I'm going to put plus 5. Go, you're good. I'm going to get plus 5, plus 6, plus 7. That moves it up. Each number is a different increment. So if you want to go back and look, if I said plus 1, I moved up 1 unit. If I do plus 2, I moved up 2 squares. Plus 3, 3 squares, and so on. It just moves up. Now, likewise, we can move the graph down. What do you think is going to help move the graph down? Well, let's subtract 1. And as you can see, we've moved down 1. From the red original to the blue, we've moved down 1. Move down 2, we subtract 2. Sorry, that was 22 accidentally. Move down 3, we subtract 3. So going back to our notes, you subtract a number. We're going to subtract a number as k. So up here, what does that mean? Like here, we're going to get x squared plus 2. Here, we're going to get x squared minus 2. That's how you would write it. Now, left and right is going to be a little bit different because, as you can see, this says negative h. So we have to do the opposite of what we think we should do. So if I wanted to move right, normally I would add, and remember, this one's in the parentheses. I would normally add, but this is going to be different, so I need to subtract. So let's say I want to move right 1, I would do minus 1. And as you can see, from the red to the blue, I've gone to the right one. If I want to move 2, I go minus 2. 3 minus 3. So in here, you're going to place a number in for h, but you have to be careful because to move to the right, h is going to be negative. So to move the graph to the right, you're going to subtract from x in the parentheses. This is purple. You're going to subtract from x in parentheses. It has to be in parentheses. If it's out of the parentheses, that's where you get your up and down. In the parentheses, left and right. So this is where you're going to get like x minus 2 squared. And you can put the y in front. You don't have to. Let's do that in black since everything else is in black. Trying to keep color schemes here for you guys. And then if we're going to move to the left, it's going to be the opposite. So if I subtract it on 1, maybe I need to add. So now if I want to do this, we're going to add 1. I move to the left 1. Add 2, move to the right, left 2. Add 3, move to the left 3. So the big thing with horizontal translations, and eventually stretches, shrinks for horizontals as well, it's always going to be different what you think. So here, I'm going to add from x in parentheses. Add 2x, not from x. Add 2x in parentheses. And that's going to look like x plus 2 squared. So in the parentheses. Now say I want to stretch this. And a stretch, and I'll do this. A stretch is when it narrows. So it's going to get narrower. A stretch narrows. So say I want to stretch something, and that's to narrow a graph. So I'm also going to put a stretch here. To stretch or narrow the graph, I need to make a, or the number in front of all this, a whole number. So let's see. This is the original is the blue, and if I put a 4 in front, oh sorry, the original is the red. If I put a 4 in front, I get the blue. So I stretched it. If I put 10 in front, it stretches even more. If I put 12 in front, it stretches even more. Or 112, sorry. So to stretch or narrow, I'm going to put a number. A is going to be greater than 1. A is going to be greater than 1. It could be 1.2. It's still going to narrow it. And as you can see, if I put 1.2 here, it slightly narrows it. Now, the other way we can look at this is to widen a graph. We call that a shrink because it vertically shrinks it. Like this vertically stretched it. A shrink, also known as widening, makes it go like this. Makes it go like that. And so to vertically widen a graph, if a whole number or something greater than 1 narrows, to widen a graph, you're going to have something less than 1 but greater than 0. That's when you're going to get your fraction. So the blue one's going to be the changed one. So 0.5. The blue one, hello, Doe. The blue one is now wider. Let's say 0.1. It's wider. It widens the graph or vertically shrinks the graph. So again, A is going to be greater than 0, but less than 1. So generally, A will be a fraction or decimal. Now, how do both of these look in equations? So this is going to look like 2x squared. And this one's going to look like 1/2 x squared. And lastly, and as you can see, this one's flipped because we're going to flip. And if you notice, this was wider. This was narrower. See, I was trying to come up with something fun. So to flip the graph, And we did this. How do I make it a frown? An upside down, concave down. We did this yesterday. So to flip the graph, remember, that's when you're going to put a negative in front. So a negative, and it could be a -4. That's going to flip and stretch, or flip and stretch. Yeah, could be a -0.2. That's going to flip and widen. It's just that a negative has to be in front. So to flip the graph, I should, and you can write this upside down or right side in, it's whatever. You're going to have a negative in front. So A will be negative. And that's when you get concave down, if you remember that. All right. So all of these should help you with your activity today. Definitely make sure you have this out in front of you and just play with it. It's going to take some time, and that's perfectly fine. But the more you do, the better you're going to be later on. And I really want you guys to be successful in being able to transform these graphs. I hope you have a wonderful day, and I'll see you tomorrow.